We're going to solve polynomial and rational inequalities. Inequality just meaning that we have less than or greater than symbols rather than strictly equals to. And the way we're going to do this is make a sign chart using x-intercepts and discontinuities. So in the first one, we have this basic parabola, and we want to know what x values can you substitute in to get answers or y values that are less than 0. So if we say, for example, put 0 in for x, we get negative 24 is less than 0, which is true. So that means 0 is part of your solution. If we put in 1, we'd have 1 minus 5, subtract 24, that is also less than 0. So 1 is also part of your solution. So the idea here is, rather than just getting solutions like x equals 1, x equals 7, x equals 2, we're going to get intervals of answers. Okay, so the inequalities will introduce intervals of answers. So if we pull this up on the calculator, how do we get answers that are less than 0? So what x values give us y values that are less than 0 or negative? Anything below the x-axis will be negative y values. And it's very important here to recognize the difference between the x and the y value. Now, this may seem obvious and it's kind of silly to say, but a lot of students make this mistake is they say they don't understand the difference between x being negative and when I say you have to get negative answers. Well, negative answers are below the x-axis. So when you find the x-intercepts, that will tell you where your cutoffs are from where your function goes from positive numbers to negative numbers. So what we need to do is factor and solve, or use quadratic formula, however you solve for the x-intercept, so when y equals 0, and then we're going to make a sign chart around that. So what I want you to do is I want you to solve the first 3 by getting your function equal to 0 and then factoring or using quadratic formula to find the x-intercepts. So I'll pause the video and I'll put up the answers. So in the first one, that factors to x minus 8 times x plus 3. So the zeros or the x-intercepts would be x equals 8 and x equals negative 3. Now I want to emphasize probably the biggest thing that I see students do that is wrong is they say x minus 8 is less than 0 and x plus 3 is less than 0, then they solve that, and then they get inequalities right away in their answers. That is 100% wrong to do it that way. The idea there is you're multiplying x minus 8 times x plus 3 and getting a negative answer. So you can't just set each of these expressions less than 0. And the idea there, without getting too into depth, is to say you can multiply a negative times a positive to get a negative, or you can multiply a positive times a negative. So there's different scenarios that'll give you negative answers. So you have to be very careful. If you set both of these less than 0, what you're saying there is a negative times a negative, and a negative times a negative is a positive, which is not less than 0. So again, I don't want to harp too much on that, but that's a huge mistake that students make, and they keep on missing it and they don't understand why. That's why we're going to set up a sign chart. So what we do is we put the values that we care about, the x-intercepts, we put those on a number line, and then determine on that number line where do we have positive and where do we have negative values. So once we have the factored form, it's actually easier. So if I put in a number to the left of negative 3, so say like negative 10 or even like negative 100, if you put a negative number in that's less than negative 3 here, you would have a negative number here and a negative number here in this factor. When you multiply those, you get a positive answer. So that's why there's a plus sign there. If you're between negative 3 and 8, so 0 is a nice number, you would have negative 8 times positive 3, which is negative, and that's less than 0, so that's true. Okay, so that's a negative answer, so that's going to be part of our solution. Go to the right of 8, so put in like 10, you would have a positive times a positive, which is positive. So that's why there's a plus sign. So that's not part of your solution. So our solution, how do we get negative answers, or numbers that are less than 0, is any x value between -3 and 8. Now this is where you have to really pay attention. Notice that it's just less than, it's not less than or equal to. So -3 and +8 are not included in your solution. So -3, 8, that's your interval notation, and here's your set builder notation. Okay, so that's just a basic example of the process we go through. Do the same process for the next two, number 2 and 3. And if you need to pause the video again, go ahead. I'm going to put the answers up though. These are a little more complicated. In number 2, you have to use the quadratic formula. Number 3, you have to use a GCF factoring, and then it factors again. So we find the x-intercepts, or the zeros, and then just put a number in each of those intervals. Okay, and we get our solutions here. Okay, so again, just to be clear, when you have 3 x-intercepts, you put them all 3 on your number line, and then take a number to the left of -5/4, like -10. We'd have a negative times a negative times a negative. So if you multiply 3 negatives, you end up with a negative answer. A number between 0 and -5/4, like -1. You'd have a negative, and then that'd be -4 plus 5 is positive, and then a negative. So there you have negative, positive, negative, which is positive. Okay, and then do the rest of it the same idea. Okay, so those are polynomial inequalities. And if you look at the graph on the last one, number 3, the graph can really help you. So if we're looking at this polynomial function here, we have the factored form. We have the zeros, -5/4, 0, and 3. And we can see we're looking for numbers that are less than or equal to 0. So it's below the x-axis here on the graph. So that's how the negative shows up here. So if you have trouble substituting a number in, you can also look at the graph to help you. When you're between -5/4 and 0, so this little section right here, notice we're positive because we're above the x-axis, so y is positive. And then between 0 and 3, we're negative because we're below the x-axis. And then to the right of 3, we're positive because we're above the x-axis. So you can use your graph to really help you out. So this shouldn't be too difficult to do. It looks like it's a lot, but it shouldn't be too crazy. So if we look at the last few with the rational inequalities, now we want to find x-intercepts and also the vertical asymptotes. So I have number 4. What x values can we substitute in to get numbers that are less than 0? These are more difficult than the polynomial inequalities because of the vertical asymptotes and discontinuities that are happening. So if we look at the graph of this, so I have it in my calculator here, and graph it, we have a vertical asymptote, it looks like here, and then another one over here. It's hard to see what's happening kind of in the middle here, but what it looks like it comes down and then connects to this little section over here. Your calculator is probably just having a hard time graphing it. So let's see what's happening in this section right here. So like when x is -2, 3, -4. If we trace it and just use the arrow key to scroll to the right, notice that we are getting answers on the graph. Okay, here we have when x is about -3, we're just below 0, and then eventually after maybe around -4 or so, it looks like we go above 0. So we are getting a connected graph there. So we know there are solutions here. But we went from a negative to a positive, so we know that there must be an x-intercept in there somewhere. Okay, so what we're going to look at is factor the denominator to x plus 8 times x minus 3, we see that we have vertical asymptotes at negative 8 and 3. The x-intercept will occur when the numerator is 0. So notice the x plus 4 factor did not cancel out. So that means that x equals negative 4 is your x-intercept. So put all those values on the number line, negative 8, negative 4, and 3. Make sure you put them in order, on like a number line would be. Some people try to put the asymptotes and then they'll put an intercept. Well, you have to make sure that the numbers are in order. Now, that may sound obvious to most people, but that is something students mess up on. Then they wonder why they're getting these weird answers. Okay, so if I look at the graph again, we want to know what values for x give us negative answers. So it looks like we're below the x-axis to the left of negative 8. So that gives us negative answers. It looks like when you're to the right of negative 8 to negative 4, it looks like we're above the x-axis right here. And then we have our x-intercept. So if I press trace on the calculator and put negative 4 in, that's where we hit our x-intercept. And then after that, we go negative. So between negative 4 and positive 3, we get negative answers. Okay, so minus. And then to the right of 3, we're above the x-axis, so we get positive. And you can also get those signs by substituting in values for x in that interval. So for example, if x is 10, you'd have positive 14 in the numerator. And then if x is 10, that'd be 150 minus 24, which is positive. So you have a positive divided by a positive, which is positive. So what is part of our solution? To the left of negative 8, so negative infinity, negative 8. There's a parenthesis with that because on the graph, we had a vertical asymptote, which is not defined there. So x is undefined. So we can't put a bracket there. So that's something you have to pay attention to. When you have a vertical asymptote, that can't be part of your solution. An x-intercept may be if there was an equal to. Here, less than or equal to. But a vertical asymptote can't be part of your solution. Okay, so you can finish writing that down, and then I'll put up the answers to the last two. Okay, so there's number 5. Notice there's a vertical asymptote at negative 1. So that's why we had to break it apart right there. And then the answer to number 6. Okay, this one is a bit more to do because you need to get 0 on the right-hand side. So I subtracted that fraction from the right side. Get a common denominator, x times x minus 3. So the first fraction needs a x minus 3. The second fraction here needs an x. This last fraction has everything you need. And then when you combine like terms and write it as one fraction, you get this fairly simple rational expression. So the inequality here, less than or equal to 0, you find the x-intercept, and then the vertical asymptotes, and then there's your solution.